Ladies and gentlemen, welcome to the final lesson in Math 20-3 for this crazy, crazy semester that we've had. If you've made it here to this final lesson, you need to give yourself a real big pat on the back and be very proud that you stuck with it. And I'm very, very thankful and proud of you that you have gotten this far. So our last lesson is on circle graphs. We've been talking about different graphs, broken line graphs, bar graphs, and histograms. A circle graph is a different version of graphs. You've seen them before. We're going to do a little bit of math, though, in this one. This one has a little bit more math than the other graphing sections that we've been going through, in that we have to kind of find some percentages and some angles so we can actually build a circle graph. I'll explain what I mean in a second here. But first of all, a circle graph is used to display how a whole is divided. So if I've got a whole section of something, it's a good way to display how that whole is divided up. You might have heard the word pie chart as well. It's the same thing. A pie chart is like a pie split up into different sections. The sectors of the circle represent parts of the data. So for instance, in this example, we have a circle graph. It shows how people in Maxine's office building get to work. There are 350 people working in the building. So of those 350 people, 61% of those people take a car by themselves. 22% of the people take public transit. And you can see the legend here relates to each kind of section. Okay, so a legend is super important. 9% of the people carpool, which means they drive, but they take more than one person with them. So they've got a group of people in the car. 5% bike, and 3% walk to work. Okay, so the overwhelming majority of people take a car by themselves, which is not necessarily the most environmentally friendly thing to do, but that's how I got to work most of the time when we were driving to work. So that's a pie chart or a circle graph, and you can see it's very easy to see kind of what the biggest section is or how these sections relate to each other in terms of general size. Here are some questions that we would be expected to answer, though. A says, what percentage of the people walk to work, and how many people does this represent? So the percentage of people that walk to work, well, let me just get my pen back here. The percentage of people that walk to work is the smallest percent here. It's the black one, so it's 3%. 3% of people walk to work. The second part of the question, how many people does this represent? Well, what we have to do is we have to find 3% of the total number of people that work there. There are 350 people that work there. So 3% of 350, the way we find that is we take 3% and convert it to a decimal. That means divide it by 100. So we have 0.03, and then we multiply the percentage as a decimal. We multiply that by 350, the total number. So 0.03.03 times 350, that gets us 10.5. Now, we can't have 0.5 of a person. And so we're going to round that up to 11 people. Okay, so 3% of 350 is 10.5, which rounds up to 11 people. So 11 people walk to work, approximately 11 people walk to work. Now, the reason that we got 10.5 is that when we did the survey and we found 3%, it might have actually been, like 2.89% or something like that. And then in order to make the pie chart look nice or make it a little bit easier to find the numbers, they probably rounded up to 3%. Okay. And so that's why we then had to round to 11 people. But because we had 10.5, I'm going to just say 11 people. Now, B says, what percent of people come to work in a car? Okay, same idea. Let's take a look. The car, well, we've got two sections of that. We've got a car and we've got a carpool. And so all of those people, they might take a truck or something, but I'm reading the question as if I'm going to include both a car and a carpool. So I'm going to add those two percentages together. The car alone is 61%. The carpool is 9%. So together, 61 plus 9, I have 70% of my 350 people. So to find the number of people, I'm going to take 70%, divide it by 100, which means I have 0.70. Let's erase that. 0.70. And then I'm going to multiply that again by the 350 people that I have total. So 0.7 times 350 is 245. 245 people. So 70% of the people take a car, whether it's alone or in a carpool, which means 245 of those people of the 350 drive in a car. C says, consider those who carpool, walk, or bike. Is this more or less than the number who take public transport, and how many more or less? All right, so a little bit more math here. Carpool, walk, and bike together. Carpool is 9%. Walk is 3%, so plus 3%. And bike is, if you go back up to the graph, 5%. Okay, so when I add all of those together, it's 9 plus 8, which is 17% total. So as a number, that's a percentage. As a number, if I divide 17% by 100 and then multiply by 350, so it's 0.17 times 350. As a number of people, 0.17 times 350 is 59.5. 59.5. So I'm going to round that to 60 people. I'm going to compare that. That's the number of people who carpool, walk, or bike. I'm going to compare that to the number of people who take public transit, which is 22%. We can see that the public transit, there'll be more people who take that, but let's find the actual number of it. 22%, the actual number of people, it's 22 as a percentage. Divide that by 100 and times it by 350. That's the number of people total. I hope you can see the process that I'm going through each time. It's 0.22 times 350, which is 0.22 times 350 is 77 people. So how many more or less people, the question asked? Well, the number of people who carpool, walk, or bike is 17 less than the number who take public transport. Because I have 60 people who walk, carpool, or bike, and I have 77 people who take public transit. So you could say 17 more people take public transit. Okay, I hope that makes sense. I've got one more example for you in another video.